PN junction diode working. A PN junction diode is a two-terminal electronic component made of a P-type semiconductor material and an N-type semiconductor material that are joined together. The P-type material is doped with impurities that create a surplus of positively charged holes, while the N-type material is doped with impurities that create an excess of negatively charged electrons. When the P-type and N-type materials are brought into contact, the electrons diffuse across the junction from the N-type material to the P-type material, leaving behind positively charged ions. This creates a depletion region near the junction where there are no free charge carriers. If a voltage is applied across the diode such that the P-type material is connected to the positive terminal and the N-type material is connected to the negative terminal, the depletion region narrows and current can flow. This is called forward biasing. If the voltage is applied in the opposite direction, such that the P-type material is connected to the negative terminal and the N-type material is connected to the positive terminal, the depletion region widens and no current flows. This is called reverse biasing. When the diode is forward biased, the electrons and holes recombine at the junction, releasing energy in the form of light or heat. This is the principle behind light-emitting diodes, LEDs. The behavior of a PN junction diode can be described by its current voltage characteristic, which shows how the current through the diode varies with the applied voltage. In the forward direction, the current increases exponentially with the voltage, while in the reverse direction, the current is negligible until the breakdown voltage is reached, at which point the current increases dramatically.